Okay. Now, recording start. Okay. Okay. So, multiplication concept in matrices. So, in a matrice, it is not necessary that order is equal. Okay. So here we will follow the basic concept of the matrices in a multiplication. For example, we have a row and column like this. I say A is equals to 1, 2, 3, 4. And here, if I say 1, something else, I can write like 3, 5. So the order is here 2 into 2. And order is here number of rows 2 and column 1. So in this case, if I say the number of columns in the first matrix. So how many columns we have here? It is always in the row and column format. Row and column format. So number of column is 2. And in the other one, if I say the number of rows is 2. Okay. So in a matrix first, if the number of column, you can say like this way, the column in the first is equals to row in the second. Row in the second. Then we can able to multiply. So it is true in this case. We will see the column is 2 and here row is the 2. So we can able to multiply. Also, we cannot able to add these two matrices or also cannot subtract. Because that time it is required both matrices have a same order. But in this case, order does not matter. Only the column in the first is equals to row in the second. Then we can able to multiply. This is the very important concept in multiplication. It's not like a multiplication of the common mathematics, like you can multiply this and you will get the 6. No. Because in the common math, we can always get one number at a time. But in a matrices, or we can say in a Excel, we can always multiply multiple number at a time. Okay. So it can deal the many numbers at a time. So the column in the first is equals to row in the second, then we can able to multiply. Okay. Some properties. In a multiplication, in count multiplication, if I say 2 into 3 is equals to 3 into 2, is it? But matrices, it is not true. Okay, means A. Okay, so it is not necessary that equals means AB does not necessary that they are equals to BA. Okay, also, but we can define the associativity in means you can multiply BC then A. Okay, or A B then C. So it is true, but the commutative is not right. Multiplication distribution is also true. You can add and multiply, or you can multiply then add. Both is right. If A and B are two matrices, then if AB is equals to 0, it does not imply that both are 0. Okay, or any one of the 0. What does it mean? Anyone can explain me? Only 3 students. Fine. So the point is here, the question says that 2 into 0 is how much? Anyone? Anyone can answer me. Okay, fine. So usually it is 0, isn't it? Else, if I say that 0 into 2, it is again 0. Or you can say both are 0, then only have a 0. Is it? Is it right?
Yes, sir.
But in matrix, it is different. In a matrix, if A is not 0, okay. If I say A is not 0, means none of the any at least one element cannot be 0, okay. And B is not 0, means here either first 0 or second 0 or both are 0. But in matrix, if A is not 0 and B is not 0, still multiply can be 0. Isn't it? You got my point? If A is not 0 and B is not 0, still multiply can be 0. So this is written here. Okay. A is not 0, B is not 0, then still multiply can be 0. Or here the meaning is if multiply is 0 in common mathematics, then at least one is 0. But in this case, not necessarily. That is written here. Does not imply that either 1 0 or second 0. Okay. That is representing here. So common math, we have at least one number 0, then we can 0. But here, not necessarily that both are 0, but still multiply can be 0. So this is a different maths that can deal multiple number at a time. Let's see the multiplication and then I can explain it better way. What is the order of this one? 2 row, 2 column. Am I right? 2 row and 2 columns. Here, how many rows? 2 rows, 3 column. Isn't it? So is it addition possible in this case? Anyone? Can we add these two or not?
We cannot add, sir.
We cannot add because the order is different. First order is 2 into 2 and another order is 2 into 3. What about multiplication? Okay. So for multiplication, we will see how many columns in the first matrix we have. 2 columns. It is always written in the row into column form. Okay. Row into column form. So the how many columns we have here? 2. Okay. And how many rows we have in the second one? Second one, how many rows? 2. So we can apply the number of columns in a first is equals to number of rows in the second. So we can able to multiply. Isn't it? You got my point? Now I will show you how to multiply. Is it clear, everyone? If the column is equal, then we can able to multiply.
Yes, sir.
You got my point? This is the formula. Now we can utilize the formula and multiply. Sorry. And you should keep it in above here because we have a space. C1 is equals to R2 is equals to 2. Then we can multiply. Now multiplication. What is multiplication? Write down A into B, okay? A into B. And then have a multiplication numbers here. So for the multiplication, we can go this way. Write down here column 1, column 2. Use your copy pen, everyone. Okay, row 1, row 2, and here column 1, column 2, column 3, row 1, row 2. Okay. So we will multiply this way. Okay. First row, first column. Okay. This way. You got my point? First row, first column, corresponding element multiplication. So highlighted area we can multiply. Okay. First element to the first element. So we can write like this way. 2 into 2. Okay. Maybe it is required more. So we'll use 2 into 2. Then use plus sign and then 3 into 2. Okay. Is it clear? Cross multiplication. 2 to 2, 3 to 2. And then addition. Now, again, apply the concept first row, okay, as it is, with column 2, then column 3. Okay, then first number will appear as a multiplication number. So we'll write here what 2 into 3 plus 3 into 4. Okay, again, the next one is 2 into 1 plus 3 into 2. Okay. So this is the first rows elements. Next one, we can go with the second row and repeat all row, column 1, column 2, column 3, one by one. Okay, for column 1, 4 into 2 plus 5 into 2. Again, here 4 into next one, second row, and then third row. Okay, so for second row, 4 into 3 plus 5 into 4. Then 4 into 1 and then 5 into 2. 4 into 1 and 5 into 2. Okay, so the order is, simplify all this. 2 2s are 4, 3 2s are 6. 6 plus 4, 10. Okay, here 3 2s are 6 and 4 3s are 12. 12 plus 6, 18. Okay, 2 1 is 2, 6 2 8. Next one, 4 plus 2, sorry, 4 2s are 8, 8 and 10. 18. Here 4 3s are 12 and 12 plus 20, that is 32. And here 4 1 is 4 plus 10, that is 14. How many rows we have now? 2 rows and 3 columns. Any doubt in a multiplication? Anyone?
No, sir. It's okay. Understand.
Okay. If you understand, you can see here the multiplication rules. Okay. Like this way, C11 column 1 means what? The row 1 multiply by the column 1. Okay. Then row 1 multiply by the column 2, row 1, column 3. Then row 2, column 1, row 2, column 2, and row 3, column 3. And keep all the values like this. Okay. If I want to go with the BA, is it possible in this case? For example, if somebody says that find BA. So in the BA, what is the order here? 2 into 2 and here 2 into 3. So how many columns? B is the first, so we'll see here as a column 1. So column 1 is equals to 3 and here row 2 is equals to 2. Both are equal? Not equal. So BA is not possible. AB is possible. So it's the best example where we can multiply AB but cannot multiply BA. Okay. So what is the multiplication rule? Multiplication rule says that the column in the first must be equal to row in the second. Okay. In this case also BA is not possible. Okay. So can you multiply this question, everyone, and find the multiplication of AB? Please find the multiplication of this question in the same way. Anyone doing or not? Multiplication of this number.
Yes, sir.
So we will write like this way. AB. Okay. So rule is what? First row. This is the row 1. Okay. And this is the row 2. This is column 1, column 2, and this is only column 1, row 1, row 2. So first row, first column. So what we will write? 1 into 3 plus 1 into 3 plus 3 into 5. Okay. Next one. First row, first column. There is no other column, so only one element you will get. Okay. Only one element. Again, second row, first column. So 2 into 3 plus 4 into 5. Simplify. 3 plus 15. Here 6 plus 20. So this will become what? 18 and 26. This is the multiplication. Okay. Please do multiply this question. Done. Okay.
Yes, sir. I got it 1826. Correct, sir.
Yeah. Okay. Similarly, we have a more multiplications. Okay. For this question, everyone multiply. Find AB. So how many rows here? 2 rows, 3 column. Here, 3 rows, 2 column. Okay. So how many columns in the first we have? 3. Okay. So column in the first is equals to 3 and row in the second is equals to again 3. So multiplication is possible. Am I right? So find AB, everyone. Find AB like this way. Find AB and check whether it is right or wrong. Done.
Doing, sir.
Okay. Okay.
Confirm that it is correct.
Is it correct?
Yes, yes, sir. 13 ones 27 0.
Done. Done or not? Hello. Anyone doing or should I continue?
Finish, sir. Done.
Okay. Similarly, we have a BA and you will see the BA is completely different with the AB. AB is 2 into 2 and BA is a 3 into 3. Just completely different. Okay. So AB and BA in a common math, it is correct. But here it is incorrect. Okay. Can be possible sometime equal, but not always. Here A square, if A is given, then find the A square and have identify the type of the matrix. So if I multiply A, then you will get the same matrix. So it is a idempotent type. So it's the same question on multiplication. Okay. Similarly, nilpotent, you will see it is non-zero matrix. And if you multiply two non-zero matrix, you will get the zero matrix. Okay. It's also quite easy. So simple multiplication. So this is the type of the matrix that we had already discussed in the multiplication. So now the transpose. Transpose means change the row to the column and column to the row. And these are some properties. Okay. Add these two, everyone. A and B. Add A and B and then take a transpose. Then again A transpose and B transpose. Okay. What is transpose? We will write the row in a column form. Okay. Like here, transpose of the you can write T or this prime, both will work. Okay. Like this. So transpose of the A is what? We can write this in this form, means row to the column. Okay. Second row to the column. Third row to the column. This is the transpose. Okay. For B prime, what is transpose? So we'll write row in the column or column in the row, both is right, okay? Is up to you. Okay, so this is called transpose. Clear? So if I add A and B, so what I get after the addition? 2 minus 1. How much? Hello. 2 minus 1. Anyone knows about?
2 into minus
Hello.
1, minus 2.
No, not
2 only.
into. Addition.
Addition.
It is
Minus,
1 only.
it is 1. 1 only.
Okay. Minus 1 plus 0, minus 1. Okay. 0 plus 3, it is 3 only. Okay. Again, 3 plus 2, 5. Okay. 3 minus 2 minus 3 minus 5. 2, 1, 0, 0. Oh, sorry. 1 plus 0, 1. Okay. Minus 3 plus 3, 0. 0 plus 2, 2. 2, 2, 4. Okay. Clear? Now the transpose of this matrix. So we can write what? Row in the column form. So 1, minus 1, 3. Okay. And again, 5, minus 5, 1. Again, 0, 2, 4. This is called A plus B transpose. Okay. Now, A transpose plus B transpose is equals to what? So if you add these two, so 2 minus 1, 1. Okay. 3 plus 2, 5. Minus 3 minus plus 3, 0. Minus 1, 0. Minus 1. Minus 2 minus 3 minus 5. And here 0 plus 2, 2. Okay. 0 plus 3, 3. 1 plus 0. So it is 1. Okay. 2, 2, 4. So you see here these two are equal or not? Isn't it? So we can say that
Yes,
the
both are.
transpose will not affect the you can say the addition. So if you add and transpose or individual transpose and add, both are right. Okay. But for multiplication, it is different. If AB transpose you are taking, you must take B transpose and A transpose for multiplication. Okay. So that is different. You will see here AB. So it is a multiplication sign. So A multiplied by B. Please find the multiplication of AB. If you go first row, first column. Okay. So we'll get the first element. So 2 minus 2, I'll write here minus 2. 2 into minus 1 minus 2 and 3 plus 0. 3 into 0, that is 0. So you will get minus 4. Is it right? First row, first column. Clear? First row, first column. First element, first element. Second element, second element. Third element, third element. Here we will take a row element and here column element. Similarly, if you proceed for the next, then again, first row, second column. So first element 2 into 0, 0. Minus 2 minus 3 plus 3. And here 2 plus 0, 0. So the value is 3 only. Is it clear? Is it clear? You can use your copy pen. And similarly, first row, third column. So 2 into 3 plus minus 1 to 0, 0. And 2 0 to 0. So 6 only. So similarly, we can go second row, first column, second row, second column, second row, third column. Third row, first column, third row, second column, and third row, third column. We will get this. So AB transpose means we can write this in the row form, this in the row form, this in the row form. Okay. Only one if you understand, so you can multiply. Isn't it? Done? Do multiply only one or two numbers. Any doubt?
No, sir.
Okay. So similarly, we will follow the BA transpose. Okay. So if you find the BA transpose, means take a B transpose and A transpose multiplication, you will get same number. Okay. So it is for you. Orthogonality. What is orthogonality? Orthogonality says that if you A and A transpose multiplied, you will get I. Okay. That is called orthogonality. So first thing you should write down the 1 by 3 and transpose of the 1 by 3. Okay. Means row to the column. This row must write down in the column. Okay. In the column. And 1 by 3, 1 by 3 become 1 by 9. And if you multiply first number, please check it is 9 or not. Everyone. First row, first column. That is underlined here. Means you can multiply this row to this column. Each corresponding elements. Okay. Like 1 into 1 plus 2 into 2. Okay. Plus 2 into 2. Is it 9? Is it 9? Everyone? Is it 9 or not?
Sir, which is the answer 9?
Hmm?
1, 2, 2 or 1, 1, 2, 2, sir.
Is it right? See, first element multiplied by first element, second by second, and third by third. Okay, and then addition. Hmm? Done? Use copy pen.
Yes, sir. Yes.
Right? Please check whether you are right or not. Very simple. 1 into 1, 1. 2 to the 4, 2 to the 4. Addition become 9. Okay? Done?
No, sir.
Do this. Write down on your copy and then you can able to understand. Now again, first row, second column. Okay. In this case, first element multiplied by 1. So that is 1 into 2. Okay. Then plus second element to the 2. 2 into 1. And the last element is what? 2 into minus 2. Am I right? Hmm? First element to the first element, second element to the second element, third element to third element. Okay. It is of is it theory? Your values.
Yes, sir. Done.
So similarly, check all other values. Check the third one is also 0. Then again, second row, first column, second row, second column, second row, third row, first column, third row, second column, third row, third column. And check your values. Please check
Also
everyone.
0.
And this you will get this values. Done?
Yes, sir. Done.
Okay. Is it right? All 9 values.
Right,
We
sir.
have a 9 values. This process you should repeat for each values. Like first row, first column, first row, second column, first row, third column, then 3 elements. Second row, first column, second row, second column, second row, third column, then second row is over. Then third row, first column, third row, second column, third row, third column. Done? Done? So, okay,
Done,
so we'll
sir.
continue. Okay, now if you take 9 is common among all, or you can divide by the 9 here. So 9 1 is 9, 9 1 is 9 1. So it will become I. So if any matrix that have A and A transpose is equals to I is called orthogonal. Okay, this is the property of the orthogonality. Cofactor adjoint of a square matrix. We had already discussed about the cofactors. Okay, so we will omit it. And we had already discussed about adjoint. So firstly find the adjoint, then the through that we can find the inversion of the matrix. So what is adjoint? Adjoint of A is equals to transpose of the cofactor matrix. Okay, cofactor matrix transpose. So cofactors we had discussed yesterday in determinant. Similarly, we can find the cofactor here. Okay. So for example, if I assume it is A, then adjoint of the A is equals to what? So first we will find the cofactors. Okay. And then the adjoint. Okay. So what is cofactor? So if what is the location of this element? Huh? Anyone? A11, am I right? Hmm? Hello. What is the location of this element? We had discussed yesterday. The determinant similarly here. The location is 1, 1. So 1 plus 1 is 2. So even number. Now finding the cofactor, we will delete the corresponding row and column. What you see, you should write down here. What is the value? Visible value? Hello. What is the value here? 4. Okay. Is it right? For the first element, it is 4. Hello. We had discussed yesterday about this. Hello.
Yes,
No one
sir.
here?
Yes, sir. That is, it was 1 1. That is 2 2.
Hmm.
That is also 1 1.
Okay, fine. So similarly, we have a other values. So the next value is, I will delete all this. The second element is what? A12. This one belongs to the column 2 and second row. So what is the value? A12, 3. But 1 and 2 is a 3. So it is odd number. So we'll take a minus sign here. Okay. Again, for the next A21. A21 is again a minus. And we will write here 1. Then A22, last number. So A22 is this row and this column. That is minus 2. If I take a transpose, so we'll change the row to the column. So we'll write here 4 minus 1 and here minus 3 minus 2. So this is called adjoint of the edge. Okay, please check. Similarly, we will follow for 3 into 3 in the same manner. But their adjoints, cofactors take a time. Means we will go with the 3 into 3 concept. Complete 3 into 3 concept. Done? Any doubt in this step? No. Any doubt?
Sir, I'm not understanding this cofactor, sir.
You are there in the studies class.
Yeah, I was, sir, but I'm very much confused with this cofactor, sir. This,
See,
especially this one taking the signs. This one you are telling odd number and even number, and then you are taking sign minus and plus. This one I'm confused, sir.
okay. I'm going to repeat the point is you must be attentive in the classroom, okay? And use copy pen, then only you can understand this concept. Okay. But going to repeat it again. Yesterday I had discussed about the cofactors, okay? CIJ. The formula is minus 1 to the power of I plus j into mij, okay? You know about the minus? Umesh,
Yes,
you
sir.
know about the
Yes, sir.
minus?
Yes, yes, sir.
Okay, same thing we will apply here. Okay, so the locations are 1, 1, first row, first column. So we will write like this way, A1, 1, okay? Again, A1, 2, okay? Here, A2,
Yes, sir.
1. It's not 21, it's A2, 1, and then A2, 2. These are the location like Excel sheet. If you go in Excel sheet, it also show you the location. So the location sum 1 plus 1. If you keep here 1 plus 1, what do you get? 2 minus 1 square is what? It become plus. Okay.
Plus,
Similarly here 1, 2. If you add the 1 and 2, you will get 3. So it is minus. So the sign
uh,
convention says that if the sum become even number, so we will take plus sign. And if it is odd
okay.
number, we will take minus sign. Okay.
Okay.
Like this
Okay.
way that we had
Okay.
taken here. Also, how to get the cofactors? So cofactor concept says that, for example, first element. So first element is this, belongs to first row, first column. So delete that row and column where the element is belong. Okay. And whatever you see, you should write down here with the sign. The sign is plus and the number is 4. Okay. Is it clear? First element.
Got it, sir. Yes.
Second element. Second element. Second element is this. Okay. So here we will delete the row, particular row where the element belong and column also. What you see? 3. But the
Three
value is
only.
minus. So we will take minus sign.
Minus three. Okay, sir.
Okay. Similarly,
Yes,
these
sir.
two element. So
Okay,
use
sir.
your
Got it.
hand gesture in your copy. Write down this and hand gesture and delete the particular row and column. Then you will get the answer. Okay.
Got it, sir.
Please, where the element is belong, we will delete. Okay. Now 3 into 3. This is the standard answer. You can check the standard solution. That is also true. So this is a cofactor matrix. If you take transpose, it becomes the adjoint. Next one, second. So this one. The cofactors of all means the 3 into 3. So in the 3 into 3, this concept become more, you can say more complicated. Okay. So you should write down this formula. I'm going to delete this and I will show you how to solve 3 into 3. The formula is same, okay? But the solution is required the solution, okay? Required solution for this 3 into 3. So again, you will write here all the values, okay? Here write down R1, R2, R3. Here column 1, column 2, column 3. Sign conventions. So if I say the sign convention is first element 1, 1 plus 1, 2, 3. So 3 means minus 1, 3 plus 2, 1 minus 2, 2 plus 2, 3 minus 3, 1 plus 3, 2 minus 3, 3 plus. Okay. First element. So if I say the C11, okay. C11 I will explain you and other you should find yourself. So C11 plus sign And this is the C11 element. Am I right? Hmm? Is it a first element?
Yes, sir.
Yes,
Is it
sir.
right? So you can delete this row and column, then you will get 2 into 2 matrix. Okay. But we will write here the determinant form that we had discussed yesterday, determinant form. So values is what? -4, 2, 4, 3. Simplify. So 4 3 ja 12. 4 2 ja 8. Become what? -20. Okay. Is it right?
Yes,
-20.
yes, sir.
So first element is a -20. Should write down. First element is a -20. Now we have a 9 elements. Find all the 9 elements. Okay. So C11 is this. After this, we will delete it. Find other elements. So second element is what? C12. So you see here 1, 2 means minus. We will take a minus sign. Okay. And the matrix. What is the matrix? Delete the particular second element. Okay. This row and column where it belongs. Okay. Done. Hello. You got my point? Where the element is belong, we will delete that row and column both. Okay. And whatever you see, you should write down here after deletion. And simplify, cross multiply and minus. 3 1 ja 3, 2 0 ja 0. Answer is 3, but with minus sign. So the answer is -3. Okay. Done. Any doubt?
No doubt, sir.
Use your hand gesture on your copy. Okay. Where the element is belong, delete. And whatever you see, it become the 2 into 2 determinant. Solve. Similarly, if I say 1 3, so 1 3 means 1 3 means third row, first column. So we will delete the third row and first column. Okay. Third row, third column and first row. Okay. What is written here? This is 1 means first row, third column. Okay. The meaning is what? We always write row first and column second. So we can delete these two. What you see should write down here. The values are 1 0 minus 4 4. Cross multiply. 4 1s are 4 and here 0. Location is plus. So value is also plus. So this is the third element. Now 6 more element is remaining. Please find other elements, 6 other elements. Same way. Everyone find the 6 other elements. Same way. Please tell me about what is the other elements. Like the first next element become what? 2 1. Okay. Second row, first column. So now you can delete what? Second row, first column. Means this and this. And what you see should write down. The location is odd because 2 and 1, 3 and determinant. Cross multiply. 3 2 is a 6, 4 1 is a 4. -12. Done? Hello? Doing or not?
Doing, sir.
What is 2 2?
-8. -8? -10.
-8.
-8 and -10.
Should I do 2 means these two you should delete it, isn't it? Huh? So 2 is plus,
Okay.
and the values are minus 2, 1, and 0 and 3. So 3, 2 is 6. Minus 6. Am I right? Minus 6. This is the element, so we can delete this row
Yes.
and this column. And whatever issue should write down. So minus 6 is your answer. Okay. Okay. Similarly, we
Yes.
can find all other elements and then take a transpose. Means write down this row in a column. Okay. Then become the first. You can see the column. And the minus 10, minus 6, and other elements. Okay. So this is your work to do. Okay. All elements and find the transpose. I have a solution. I will show you. This is the solution. Okay. Through that you can get the answer. Maybe some typographical error in the solution. Okay. So do not follow the solution. You can follow your own. Adjoint and the inversion. So I will go with the inversion directly, not this question. Okay. The inversion. So inversion says that if AB multiply, we will get I. Okay. So inverse formula is A inverse is equals to, maybe I have written here as well. Not it, yeah, this one. The A inverse is equals to, this is a formula, adjoint of A upon determinant of the A. Okay. So through this you will get the inverse. Okay. So we will utilize this formula. Inversion is only possible if your determinant is not 0. Okay. If the determinant is not 0, then we can invert the matrix. For this question, find the inverse. So first thing we will find the determinant. Okay. Determinant. So what is determinant? Cross multiply. 3 1 ja 3, and here 3 2 ja 6 minus 6. So determinant is what? 9. Is it 0? No. So we can proceed. Any doubt? We are applying this formula. Okay. A inverse is equals to adjoint of the A upon determinant of the A, where determinant cannot be 0. Done? Any doubt in this point? Now adjoint. Adjoint of the A. So for the adjoint, first element is this. So we can delete this row and this column. What you see? Use your hand gesture like this. Write down this question on your copy and delete. 3. So we'll write here 3. Similarly, for the second element, delete this row and this column. Okay, completely. Or you can use your hand gesture or pencil on your copy. What is the value?
2.
But the location is what? 1, 2. So the signature is -2.
I,
1, 2. Row 1, row 2. Column 1, column 2. So 1, 2. Sum of the 1 and 2, 3. Okay. Clear? Okay. -2. Next one. Next one. This element. 2, 1. So 2, 1 is again odd. So we'll take minus sign. And the value is what? -3. So in the next step, it become +3. Am I right? Use your hand gesture like this to delete where element belong. We can delete. 2 1 means delete second row, first column. Deletion. Done. Done. Hello. Okay. Same thing for the last element. What is the last element? This. So belongs to second row, second column. We will delete the second row, second column. And the value is plus. If I take a transpose, so write down this 3 minus 2 and here again 3 and 1. So this is the adjoint. Done. Any doubt? Any doing or not?
No, no doubt, no doubt.
Fine. Now the inverse. We will write the inversion. So what is the inversion? Inversion says that the what is the determinant you can divide. So we will write the adjoint value here and divided by all 9. Okay, or you can divide 9 in everywhere. 3 by 9, 3 by 9, 2 by 9, 1 by 9. Okay. So it is become what? 1 by 3, 1 by 3, 2 by 9, 1 by 9. And that's all. Okay, done. Standard solution I have, you can see the standard solution. This is the standard solution. Okay. And adjoint is this. So after divide, you can get this answer. This is the another one. You can follow my solution only. Okay. Go with the video. This is as per the question. Question says that inverse a multiply is equals to I. So after the this inversion, you can multiply a inverse into a, you will get I. I means diagonally 1. That is written here. Same question again, a inverse of this third order. So the third order required what? Determinant of the a. 2, 3, 1. 2, 0, minus 1. 2, 0, 2. Okay. So in this case, we can expand from anywhere, but expanding from the 2 is very easy. Okay. Because 2 have a two zeros. So we can expand from the R2. So what is the location value? 2, 1. So it must be minus and one more minus. And we will delete what? The particular row and column where the element belong, and we can write. Okay. So cross multiply here. 2 2s are 4. 2 1 is 2 and 1 minus. Okay. So this become what? 18. 18 is not 0. Clear? Any doubt?
Can you repeat, sir?
This is a multiplication. So we will delete where the element is belong. This I will take other color. Okay, this you will delete this and this. What you see should write down 2 into 2. Okay. After that cross multiply and then minus sign. Then again cross multiply and addition. So minus 5 become plus 4 plus 2 6 6 3 18. Okay. Other two not required because these are 0. So if you take, then ultimately we will get to 0. So no need to write down. If you go other ways, again you will get 18, but other ways not have a 0, so you need to multiply, solve all the values. But here not necessary. Okay, so it is not 0. So we can proceed for the adjoints. Okay, so what is the adjoint of the A? So for adjoint of the A, you can find all the cofactors, everyone. Find all the cofactors. This is the matrix, okay, and determines it is done. Adjoint of the A. So what is the adjoint? We can find the cofactor of all the elements, like first element, then second, third, fourth, all the 9 elements, and write down here. Okay, and then finally we will take a transpose. So one I will do for you, and other you should find yourself now. For the first element, okay. So what is the determinant value here? 0 0 minus 1 0. Okay, like C11. So it is value 0, 0, minus 1 and 2. If you cross multiply, you will automatically get 0. Then similarly find C12. So this is minus because the sum become odd. And here, second element can be this. Okay, write down in a determinant form like this and find the value. Find 9 values. Okay, I'm taking the break for 4 minutes and I'll join at 10:10. But that time I will ask you what are the 9 values. Is it fine? 9 values. All the elements you should find. Solution I have. This is the solution. Okay. So and with the sign convention. So find all the 9 values, everyone. Then I will check. Okay. Any doubt? Hello. Find all the 9 cofactors like C11, C12 like this. Okay. I'm taking the break. We'll join at 10:10. Done? Anyone? Anyone done or not?
I'm done, sir.
So, okay. So, okay. Can you tell me the answers here? The next element, A12. A12 is what?
0.
A12 again 0. Next, A13.
A1. A1. 3.
A13 is this element, okay?
3.
You can do this and this. A12 is
3.
0. No, A12 is not
A1.
0.
A1 2 is 0.
A12 is not
A11
0.
is 0. A11 is 0.
A11 is
A12
0.
minus 6. A12 minus
A12 is
6.
what? Minus 6. But the A12 location is minus, so we will take only 6. 1 and 2 is odd. Sign convention you can follow like this way. Plus, minus, plus, minus, plus, minus, and plus, minus, plus. Okay, you can use this sign. What is A13? A13.
A1 to 3, sir. 3.
3. You are right. 3. Good. A21?
Minus
Hmm?
6. No. Minus
Okay,
2.
this one.
Minus 2.
4 minus 4 plus 2, 6. And with minus. So we have a minus 6. Okay. A22?
6.
A22? A22 means this element. Huh? So 4 minus 2. 2. 4 minus 2, 2. And the sum is also 2. So it is again 2, not 6. See, cross multiply 4. 4 minus 2, 2, isn't it? Huh?
Yes, sir.
A23? A23 how much?
0, sir.
Minus 2.
0.
No, no, no. Minus 2, minus 2. Minus 4.
Minus 2 minus 2
And
minus 4,
A23
sir.
minus, so plus 4.
I'm mistaking with this student science.
Okay, do correct. Next one. A31. What is A31?
A310.
A31. 0. Good. Correct. Next. A32.
6.
A32. You can use hand gesture, okay? Because I am not discussing in the classroom, okay? So you can use hand gesture to deal it like this way. You okay? Like here, like this way, like that. Okay? You can use your hand gesture. Okay, deal it with your finger, and whatever you see should write down. Okay. So the value is what? 0 plus 6, and the location is 3, 2. So minus, so plus 6. This is 0 plus 6 and again 1 minus 6. Is it right?
Minus 6.
See, minus 6 because it is 0. Minus minus become plus, but the location is 2, 3, so it is minus. Last value, ninth value. What is the ninth value? 2 to the 2 0 is a 0. 3 to the 6 plus 6 and only plus 6. So answer is 6. Isn't it? Huh?
Yes, sir.
Now transpose. Transpose means you can change the order. Row to the column, column to the row. So this is the row, I will write in the column. Or you can write the column in the row also, both is correct, okay? So 0, 6, 3, minus 6, 2, 4, 0 minus 6, 6. It is adjoint, okay? And what is the inverse? You can divide it by 18. This is the answer. Okay, done. So now, this is the inversion process and very, very important process. Others are have other question as well, like these questions. Okay, more questions are there. But based on the discussion, like B inverse, if you multiply AB inverse, so B inverse A inverse will be true. So if you know the one concept inversion, then you can able to solve the questions. Okay. All are the inversion questions, nothing different. System of the equation. So what is system of the equation here? Okay. So system of equation means 2 into 2 I will discuss, and else we will not. Like this. So pay attention in the inversion and finding the solution of the system of equations. So we can write like this way: A x is equals to B for, okay. Then we can find A is equals to A inverse into B, okay. So A inverse we will find and multiply it by the B. What is A here? A is the coefficient of the x and y, okay. What is the coefficient of x here? 2, 4 and minus 3, 1. If nothing is there, so we'll take a 1. What is B? B is the right side value, 13 into 5. And what is x? X is the variable. So what do you do to find out the A inverse? Okay. Clear? You got my point? How to write A? Coefficient of the variables. And B is a right side value. And X is a variable, XY. Any doubt till here? Hello?
No doubt, sir.
Okay, fine. Now find A inverse. Objective says that find A inverse. So what is A inverse? A inverse required adjoint. So we'll find the adjoint of the A. So adjoint require the cofactor terms. So what is the cofactor of 2? How much? What is cofactor? What is visible after deletion? Means after the omitting these lines. 1 only. Okay, good. Then I required to do this. Sorry, it's very difficult. Okay. Can you tell me the second one? For this element, we will delete this and this. What you see? After
4.
deletion
4.
these two, 4. But the location is A1, 2. So 1, 2, 3. So 3 is odd. So we'll take a here 4 minus 4. Okay. Clear?
Yes, sir.
Use your hand gesture like this way. Next one, the element of the 4. So 4 belongs to here and here. Okay. So what do you see? Minus 3. But the location is odd. So we'll write 3 only. Okay. Now again, the next one. This last element. So delete this and this. What do you see? 2 only. And the location is plus. So we'll write 2. Transpose, write down row in the column. Okay. Inversion. What is inversion? So inversion requires determinant of this matrix. So what is a determinant? 2, 4, 3, 1. Neat clean is very important. That's why I told you use your hand gesture. Okay. Okay. So cross multiply. Okay. Cross multiply of these two. So 2 and is 2 minus 3 into 4. How much? Minus minus plus 4 3 is 12. 14. Okay. Is it right? Hello.
Yes, sir. Yes, sir. Right.
Okay. So A inverse is equals to adjoint of A upon determinant of the A. So determinant is 1 by 14 and adjoint become what? 1 minus 4, 3 into 2. Okay. Now apply the formula. X is equals to what? A inverse into B. Okay. So we will use A inverse written already. Okay. A inverse and into B. B is right side value 13 and 5. So multiply and sum. So I have here solution. I will show you. This is first row, first column. So 13 1 is 13, 3 5 is 15. 13 4 is 52, 5 2 is 10. Add and divided by 14 2 is 20, 28 and 43 is 32. Okay, do solve, multiply. Here one typographical error. It is 14. Okay. These two check it is right or not. After taking adjoint and inverse, you can multiply by the B. Only this is the change. Done. Hello. Anyone doing or not?
Done, sir. Okay, sir.
Okay. So this have more applications, so you can proceed and you can try. Okay. I'm going to export this and I will send you export as a PDF. For today's date, I will write here the 6 and save. So more discussion is given for 3 into 3 different types of the solution I have given you for your practice. You can do practice and check. Okay. Now I will discuss the next module. The module is permutation combination. So you know about permutation combination, anyone? What is permutation combination?
No, sir.
Anyone? You don't know?
No.
Okay. Permutation combination is what? Your number system is completely based on permutations. Okay. Like we have only 10 digits, 0 to 9. Am I right? 0 to 9, we have only 10 digits. That's why it is called decimal number system. Okay. Similarly, for the computer, only 2 digits, 0 and 1. And through that, they created complete computer system, all the computer system based on 0, 1. So the permutation means how many possibilities are there. We can repeat the 0 also, and how many numbers we can create. That is called permutation. Okay. Like for complete different types of the words, what we use only A to Z alphabets. Am I right? Only 26. Through that we can create enormous numbers, and there is no end, endless process. So permutation says that we can create the different scenarios by using same terms. Okay, like for example, in your class, if you have a 2 seats, okay, and you have a 2 people, so they can arrange themselves like first come in the first bench. For example, 2 people are A, B. We can write like this way: A, B or B, A. Both is possible or not?
Yes, sir.
Isn't it? So these are the possibilities. All the possibilities called permutation. Combination is different. Means, for example, if you have a 3 student, you can only choose 2 of them here, but order does not matter. So combination and permutation are different, but permutation is for order matters here, and for combination order doesn't matter. I will discuss one by one. First rule is multiplication rule. In one event can occur in a m ways, a second event n ways, and the third event in r ways. Then the three events can occur in m into n into r ways. Okay. So Erin has a 5 tops, 6 skirts, and 4 caps from which to choose an outfit. Okay. So how many ways can she select the one top, one skirt, and one cap? So the ways are multiplication of all. These are the number of ways. You got my point? Multiplication. For example, men's. You have a 2 shirts and 3 pants. So what are the total possibilities that you can select? These are 6. You got my point? Like S1, S2. And here your shirts and pants, for example, P1, P2, P3. So you can take first shirt in comparison to all of them. Am I right? Huh? So this is the 3 ways. Hello? You got my point? Hello? Is it right or not? Similarly, you can take second shirt with all the pants. The total ways are 6. This is called multiplication rule. Okay, all the possibilities. Why it is important in management? While taking tough decisions, we see all the aspects, all the possibilities, and then only we can decide the best one, isn't it? Huh? For example, hiring of the particular person for your organization. So that time we check there all the aspects, all the things, all the achievements. During the firing also, we will see all the possibilities, what he has done, she has done in entire work, isn't it? Huh? So this is the way that can give you all the possibilities. Clear? You will see this example. S means cert 1 you can take with all the pants. Cert 2 also. So total possibilities are 6. Similarly, if we generalize in this case, 5 top, 6 skirts, and 4 caps, we can multiply. Okay? Done? So this is called multiplication rule. Very important rule. Second one. If the repetition is allowed, then uh, then in this case, we can write the number of times multiplication. For example, if you have a coin, okay, one coin. So what are the possibilities if you throw the coin? Anyone? Throwing up the coin, 2 possibilities, head and tails. But if you throw the 2 times same coin, what are the possibilities? What are the possibilities if you throw the coin 2 times? Huh?
4 possibilities.
4 possibilities that are head, 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 tail, tail, head, tail, tail. 4 possibilities. So actually we are multiplying. Similarly, if you go with the three times, so you have a 8 possibilities, 2 to the power of 3. So similarly in the dice example is written here. If you throw the dice 2 times, the possibilities are 36. Similarly, 260. And if you throw r times, it becomes 6 to the power of r. So if one event is n outcomes occurs r times, so we can write the formula n to the power of r. Okay, clear?
Yes.
Any doubts? Okay. Repetition of an event. So what is the repetition? How many different car number plates are possible? Okay, so with the 3 letters followed by 3 digits. So if you have a 3 letters here and 3 digits are there. So what are the possibilities? 26 to the power of 3 and 10 to the power of 3. This is the number of possibilities from the plates. Okay, these are the possibilities. 26 letters. Okay, and then 3 digits. You can take a any 10 any digits from the 10 numbers. Okay, 0 to 10. Sorry, 0 to 9. We have a 10 digits. Okay, and any alphabet you can take like ABC. Here it says that if 3 alphabets are fixed, A, B, C, So we will fix these three values. So now you cannot take any value, only A, B, C is fixed. But for the digits, you can take any one of them. Probability says that the favorable ABC upon total, and then you can get the probability for the begin with the ABC. Pay attention. Any doubt? Hello. You got
Yes.
my point?
So how did the 26 come there?
If it is fixed, so now you cannot take ABC, isn't it? These are fixed.
So
After
26 is because 26 alphabet.
no, 26 not. Out of all 26, you are taking only first A, isn't it? Huh? So it is fixed. Now you
Okay.
cannot take instead of the A any other alphabet.
Okay.
So A is a 1 out of 26. Am I right?
Yes. Yes.
You cannot take any other alphabet. It is fixed. A only. A only. Second, only B, only C. So only have a 1, 1, 1 because these are cannot be changed. But here you can take any one of them out of 10 digits. You can take any one of them. So 10 all are can take this position, isn't it? You can
Yes,
take
sir.
like 0, 1, 2, 3, any number. But here only A, no other alphabet. Huh? So only one can occupy this place, but this any 10 can occupy. Similarly, all these three.
Oh, okay.
Okay. Similarly, the formula says that probability, but it's not in our course. The favorable upon total, and if the total is cancelable, we can cancel. Okay. So this is the different thing probability, not in the course. Factorial notation. What is factorial? Okay. Factorial is a new thing for you. If you have math background, so no problem, you know about. If not, so it is a new thing. Factorial says that factorial 0 is equals to 1 means arrangement. How we can arrange the nothing? So nothing can be arranged one way at least. Okay. Factorial 1. So factorial 1 means only one time multiply. Factorial 2 means 2 into 1. Factorial 3. So 3 into 2 into 1. Okay. Factorial 4. 4, 3, 2, 1. Okay. Factorial 5. 5, 4, 3, 2, 1. Okay. So we can multiply only. Multiplication will give you the factorial values. So factorial of the any number is what we can just less and multiply. Okay. Remember that before 0 there is no factorial. If I am talking about factorial of the -1, so nothing factorial. It is infinite, no value. Okay. Also, it is only for whole numbers 0, 1, 2, 3, 4, and so on. Okay. So factorial means multiply till 1, not till 0. Okay. Any doubt? The new notation. Clear? Hello. Is it clear or not? Factorial notation.
Yes, sir.
Yes, sir.
Similarly, okay.
You
Now
told
this
that,
question.
so
Yes.
totally clear.
Factorial means multiply till 1. For example, factorial 5 means 5, 4, 3, 2, 1. Multiply. Factorial 6 means 6, 5, 4, 3, 2, 1 like that. Okay. Now the question, how to use the factorial. In how many ways 6 people can be arranged in a row? So for example, we have a 6 people. Okay. So we will write like this way. Box of the first position, second position, third, and all the 6. Okay. Let's see, for example, you have a 6 seats and you want to arrange. For first position, all 6 are eligible for first position. Am I right? All 6 are equivalently eligible for first position. Am I right? Hello.
Yes, sir.
Now one occupied this position means one person seated. Imagine you have 6 people and one seated in the first page. Okay, first seat. Now how many people remaining? 5. One is occupied by one person. Out of 6, anyone can take it. For the next position, we have a 5 people. So out of the 5, anyone can take this position. So one person also occupied here. Now remaining 4 and 4 position. Then 3, then 2, then 1. Okay. Clear?
Yes, sir.
For example, for same question, if you have only 3 positions. So for 3 positions, in the first seat, 6 people can sit equivalently, isn't it? So any 6 can take this first position. After that, you have 5 people and then 4 people. Other 3 people will not get any seat. Only 3 is occupied. Okay. So we'll write 6, 5, 4. Done.
So
For
only
first,
3 are fixed, sir.
3 positions are there and you have a 6 people. For example, 3 seats are there and you have a 6 standing peoples. So for first position, any one of the 6 can sit. Is it right?
Yes.
After first, 1 people is occupied the position. Now 5 is remaining. And you have a 2 seats. So for the next seat, 5 people can sit. So we'll write here 5. Anyone can sit. 5 ways we can fill. Okay, like for example, A, B, C, D, E. So out of A to E, anyone can take this position. So all have an equal possibility. So we will write 5. Is it? Hello.
Yes, sir.
Similarly, 4. Now 3 people will not get any seat. Okay, only 3 seats are there. Done. Now arrangements. Arrangement or permutation is written in this form NPR. So we can write this way factorial n upon factorial n minus r, where n is the objects and r taken at a time. Okay. Remember that n is always greater than r is equals to r. Okay. Cannot less than r. Means out of, for example, 10 objects are there. So out of 10 objects, you cannot able to choose 11 objects. Okay. Isn't it? If you want to choose out of 10, the 11 objects, it is not possible. Out of 10, you can only take maximum 10. Okay. So n can be greater than or equals to r. Okay. Not less than. So we can write the notation factorial this way as well. Means this is popular notation and this is also another notation. Okay. Both are right. So NPR out of n choose r at a time. Okay. Like 6p3. So factorial 6 upon 6 minus 3. So what you should write? Factorial 6, 6, 5, 4, 3, 2, 1 upon 6 minus 3, 3, 3, 2, 1. So we can cancel 3, 2 and we can get 120. Okay. Please solve on your copy this calculation 6p3 and we will write like this way. Okay. 6p3, 6 up, then p and then 3 small.
Yes, sir.
Do solve this question one, first question. In how many ways 4 speakers can arrange in a row? So if you have a 4 speakers, okay, 4 speakers and 4 positions means we are arranging the 4 people in a row. Okay. So for first position, any 4 can take. Am I right? After that, 1 is occupied. 3 people can take the second position. Third position, 2 people. Last position, 1 people. That is called factorial 4 or 4p4. Both is right. To multiply, what is the value? Numerical value. Use calculator also. Okay. What is the value?
24.
Both is 12, 24. Okay. 24 is your answer. Next one. How many ways can the captain and vice captain be chosen? So captain and vice captain only 2 positions. Okay. So for first, anyone can be a captain. After one become captain, for vice captain, we have only 3 people. Okay. So for second position, we have 3 only. Okay. So we will multiply 12. Okay.
Yes, sir.
Done. Any doubt? We always use this in everywhere. For example, your phone number is based on permutation concept. Okay. Every number that you see is based on permutation concept. Another example, in a flutter on a horses, there are 7 horses in a race. Okay, 7 in a race. In how many ways different orders can be the horses finish? So there are 7 positions because 7 horses are there. Somebody can take a first position, that is any out of 7 can take a first position. Okay. Then for second position, any 6 can take because first is already occupied. Then 5, 4, 3, 2, 1. Okay. So we will write here factorial 7. Is it right? Hello.
Yes, sir. Yes, sir.
If we have a 3 positions, okay, for first, second, third. So in this, if you keep the first, second, third position, any 7 first can be for any 7 of them. One is occupied first position, then 6, and then 5. So that we can write 7p3. Also calculate 7p3 and find the value. Like here, first position, factorial 7 is right. And here, this become factorial 0. Factorial 0 is a 1. Okay. So factorial 7 can write like this way. Here 7p3. So 7p3 means factorial 7 upon factorial 7 minus 3. Okay. That is what? 7, 6, 5, 4, 3, 2, 1. 1 minute. Plus I will take like this way. Divided by 7 minus 3 is factorial 4. So 4, 3, 2, 1. Okay. These are cancelled. So we can write only 7, 6, 5. Okay. So both are right. Out of 7, you are selecting only 3 positions. 7 positions are available, but we will select 3, first, second, third. So for first position, any 7 can take. Next position, 1 is taken, so only 6 remaining. Then done. Hello. It is done. Any doubt?
No doubt.
No, sir.
In how many ways can 5 boys and 4 girls be arranged on a bench if there are no restriction? So anyways, 5 and 4 can arrange. That is factorial 9. Correct? Pay attention. Is it the correct way? Any 5 and
Yes, sir.
4. So this is the simple way. Any like first position, any out of 9 can select. Okay. Then second position 8. Then third 7, 3, 7, 6, 5, 4, 3, 2, 1. Okay. Now next one. Boys and girls are alternate. So see the concept is boys and girls are alternate means first position occupied by the boy, then girl, then boy, then girl, then boy, girl like that. So boys are factorial 5 and girls are factorial 4. So we will write like this way. Okay. Is it clear?
Yes, sir.
Now I will ask you the question if you understand. In how many ways can 5 boys and 4 girls be arranged on a bench if the condition is boy and girls are in separate groups? Can you try anyone? Boys and girls are in separate groups. Same question.
5 factorial into 4 factorial.
5 factorial and 4 factorial. Means first the boys and then girls, is it?
Yes, sir.
It is not possible that girls can take first positions and then boys.
It can, sir.
It
It
can,
can.
sir, but in question it's
So we are seeking here all the possibilities. Okay, what are all the possibilities for separate groups? If boys can take a first positions, like all the boys first, then girls. So in the first position, 5 boys can occupy, then 4 girls. But it is also possible that 4 girls can take a first position and then boys. So these are 2 other possibilities as well, isn't it? Huh?
Yes, sir. It can.
So we will also multiply that 2 factorial, means 5 4 and 4 5, both are right. Okay, clear? Either first boys can take a position or girls can take position. So both are right, and we have a 2 more, means the boy and girl can change their position. That is a factorial 2, or you can write 5 4 4 5 2 times and add, and you will get like this one. Okay, got my point?
Yes, sir.
Yeah. This
sir.
question. Tell me.
Isn't it 5 factorial into 4 factorial like the whole bracket into 2?
That is also right. Whole bracket not required. Multiply is multiply. Okay. Done. Read this
Okay.
question. D number. Anna and Jim wants to stay together. Anna and Jim want to stay together. Try to solve. 2 people, Anna and Jim, want to stay together. Please try. What is the possibilities? One girl and boy wanted to sit together. So what are the
2
possibilities?
factorial into 2 factorial.
Only. Think about it. Think about. 2 factorial how? Can you tell me?
Boy, girl, plus girl, boy.
Okay. So 2 factorial. Good. And what about others? We have 9 people. What about others? Because
Plus
there
5
are
factorial into
5 boys and 4 girls.
97.
Yes.
97.
Not getting you. Into 7. No. Factorial 7.
No,
No.
9P7. Like,
No. Not right. Think about. You have a 9 positions. Okay. Like this. 9 positions. They written here also. Think about with 9 position. And you have a 9 people also. Where 2 people wanted to sit together.
2 factorial plus 2 factorial plus 4 factorial into 3 factorial.
No. Okay. Now I will answer you. It's a very good question. Okay. So pay attention. We have 9 positions. You will see here 9 positions are available. NA and Jim go together. Okay. Like first 2, like we have a 9 position. Okay. 9 position. If I write like this, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now NA Jim can take first 2 positions together, isn't it? Huh? Okay. And also, if they will sit here, if NA sit here, Jim sit here. If NA sit here, Jim sit here. If NA sit here, Jim sit here. NA sit here, so Jim sit here. If NA sit here, Jim sit here. Am I right? Okay. Hello. Is it right? So together become 1.
Yes.
AJ become 1. and remaining 7 seats. So 7 plus 1, 8. Okay. They are together become 1. And remaining are the 7 people. 7 plus 2, 9. But that 2 become 1. But is it right or not? Hello?
Yes, sir.
8 people. What about NA Jim? Why 2 is written? If NA shift here, Jim shift here. But it is also true if Jim shift first, NH seat takes seats here. Am I right? Means they can change their position as well. NA Jim, Jim NA. Okay. Is it right? Hello. You got my point? NA Jim or Jim NA, both are right. So they can change their position as well. So this 2 is also changing their position. That's why we have a factorial 2. Okay. So 2 into factorial 8. Any doubt?
No, sir.
Got my point? They can shift anywhere. If NA sit anywhere, Jim join the NA. Okay, in any position. And they can also change their positions. Okay, done? Is it clear? So this is the concept. That's why I asked you the question. Very easy question, but requires some understanding. Done? Any doubt? So if you want to understand anything, you can always create a box and then think about the positions. Any doubt? Now, if the repetition is allowed, repetition means if you have a 5 position, okay, and nobody want to sit in these 3 positions, okay. For example, you have 5 people and 3 positions. So for first position, anyone can take a seat. Is it right? Huh? So in permutation, I told you the people occupied this place, but no, cannot. He said that I don't want to sit in this position. So he can be a contender in the next position as well, and in the next position as well. Am I right? Huh? Hello? So we will write what? 5 to the power of 3. So if anything is repeating or same thing, so these repetition we must divide. Okay? So if the repetition is given in an n factorial, for example, if I write here permutation, what if I say? So you will see that t is repeating 2 times. Am I right? Huh? So if any repetition is there, you can divide in the denominator. Okay, whatever the repetitions, you can divide in the denominator. Okay, clear? Hello?
Yes, sir.
I will see this type of the question. So if you see this example, paramata. So paramata, in a paramata, we have a 4 times A, 2 times R, and 2 times T. So the exact arrangement is factorial 10 divided by repetitions. Okay, divided by repetitions. Okay. So what are the repetitions is there that they cannot be unique. For example, if I say A, so if I change the NEA, it does affect. If I write this A in the first and this A in the last, there is no sense. Huh? Is it right? That's why we should divide the repetitions in the denominator. You got my point? If I will change the A many times, what does it mean? There is no sense. Am I right? Huh? Okay. So we will divide the repetitions in the denominator, then we'll get the unique number of the arrangements. Okay. So this is the concept. Can you write about mathematics? Solve this one mathematics and find the number of arrangements. Everyone, please do solve mathematics.
Sir, can you repeat this part?
The paramata is written So Paramata have a 4 A's, okay, and R's and T's. So here, what are the repetition we should divide in the denominator? For example, why? Because if we change the R, this R to here, this R to here, it will not affect. So whatever the repetitions we can divide total factorial divided by the repetitions. Okay. Hello. 1, 2, 3, 4, 5,
Yes,
6, 7, 8, 9, 10. So 10 is there, but repetitions we should divide. I will give you another question. Raymond. Okay, here, if there is no restriction, is there any repetition? No repetition. Okay, so 6P6 is right. Read the question, everyone. Is there any repetition? No repetition.
no.
So we will not go with the repetition here. 6P6, 720. It begin with the RE. So RE not required because it is fixed. Only these 4 position can be changed. So 4P4. Okay. Hello. Hello.
Yes, yes, sir.
Yes, sir.
Similarly here, this position cannot be changed. Fixed. R, no, you cannot change R to E, E to R. Okay. Fixed position RE. R is fixed, E is also only 4 can be changed. So we can go with the 4P4. Do not start with RE. So we can subtract the total minus factorial 4. Then you will get what? Do not start with the RE. Hello. Is it right?
Yes, sir.
Some combination concept is remaining. So I will discuss in the next class. Okay. And integration differential also. And it is over. Okay. So if you interested, read about the circular arrangement. It is already shared with you. So you can also see with the different types of the possibilities. Okay. And I will discuss some combination in the next class. We require this. So I will explore this as a permutation combination. Today's state is 6.
So will it be available on LMS?
Oh, yes, it is available in the LMS. If you go through that, it is already available, not annotated. Only simple PDF is all available. Okay.
Okay, sir.
Fine. And hope you understand. Revise this. Okay. Solve the questions. And these videos are also accessible to all of you. And try to solve the questions. All the PDFs are available. You can ask to the coordinator. Okay. So you can get these PDFs. Stop this sharing. Okay. Thank you for joining. Thank you, everyone.
Thank you, sir.